Hello, my name is Syamil Bakri bin Ibrahim. My metric card is CE190170. So today I would like to explain for this Lab3 MPE. So Lab3 MPE require us to explain about this MCB from our house plan layout. We need to test for our MCB DB box to test the socket outlet, which is have the electrical or not. Okay, so this is the house plan that I already draw with the switch and the MCB on my layout. So as you can see here, the table that I do is I have MCB turn on number 1, number 2, number 3 and until number 7, which is 20 ampere. So number 1 is living hall, number 2 is room 1, room 2, room 3, living hall 2, room 4 and the kitchen. So the number of sockets as you can see here I already stated and I already put it on the house plan layout. Okay, so this is the wiring diagram of the MCB with related socket. So yes, this is just the wiring diagram for my MCB to connect the socket. So my part is 5.1 question. What is the difference between radial circuit and ring circuit in electrical wiring installation? A radial circuit is a type of fixed wiring that feeds one piece of suitable cable from one power point to another. This type of linear power circuit is commonly used to wire household equipment such as cookers and boilers, lighting points, and sockets. It is simply a length of appropriately rated cable feeding one power point then possibly going on to the next. So second, a ring circuit is an electrical system in which distribution points are connected to the main supply in a continuous closed circuit. Ring circuits are general purpose circuits and hence the main protective device, fuse or MCB, must provide protection against both fault currents and overload current as far as each socket outlet. So this is MCB, manufacturer circuit breaker. So I'm going to continue for the part which is I'm going to explain for my MCB to the at DB box and try to test the socket outlet with the phone charger. Okay, thank you.
Okay, so I'm going to continue for this MCB in my DB box in my house. So this is show that I have a lot of MCB here, which is this MCB. This is all MCB, and then this is all MCB. This is the main switch. So this is 3 I'm not going to touch. So I'm trying to test one MCB first. So I try to off this one. Okay, so now I try to go to the socket outlet. Okay, going to continue. So okay, sorry, a bit dusty here. Okay, this is the switch 1 for my socket outlet for in my living hall. I already put it and I already turn on, and then I will switch off, put in on my phone. Okay, so it already state charging, so that means when you turn off the MCB, the socket outlet for this switch 1 is turned on and I can charge phone. Okay, so okay, that's all. Thank you.
Hi, Assalamualaikum. My name is Siti Nur Yasmin. My matrix number AE180077. So this is the contribution box at my rented house in Taman University, Parit Raja. So today I will test which NCB will connected to the socket number 1 and socket number 2. When I switch on the NCB number 3, switch on the socket plug number 1, my phone is connected to the charger. But when I switch off the NCB number 3, but this socket number 1 still on, my phone is not connected to the charger. Let's try with the socket number 2. I will switch on the MCB number 3, switch on socket number 2, my phone is connected to the charger. So here we can see that the socket number 1 and number 2 is connected with the MCB number 3. Next, I will answer the question 5.2, which is explain the purpose of neutral cable in electrical wire installation. So the circuit is returned to the original power source through the neutral cable. More precisely, the neutral wire will connect the circuit to the ground or the bus bar, which is normally attached to the electrical panel. So this will cause the current to flow through the electrical grid, allowing the energy to be completely used. So that's all from me. Thank you.
Assalamualaikum and a very good day. My name is Putri Nur Nabila Isma binti Ishaq with metric number AE180049. I will explain about my house plan. So as we can see in figure 1, this is a labeled socket outlet point on my house plan. There are 7 sockets, which 6 of them are single socket and only socket 2 is a double socket. Socket 1 is situated in the socket 1 and socket 2 is situated in living hall. Socket 3 is in room 1, socket 4 in room 2, socket 5 and socket 7 are in the kitchen, and lastly socket 6 is in room 3. I have summarized the location of socket outlet and number of socket outlet related to the MCB in table 1. So next, we will move to the wiring diagram. So figure 2 shows the wiring diagram for power circuit. This is the wiring diagram that is related to the table 1. As we can see, figure 2 shows this is a ring circuit. So why this is called a ring circuit? Because a cable leaves the consumer unit and travels for each socket on the main, and when it reaches the last socket, it then returns to the consumer unit, and thus it will create a ring. So the advantage of this system is that power can reach to the socket in the circuit from both directions, which reduces the power load on the cables. So this is a setting of the socket plug. As we can see, I am using a phone charger as a load. When I plug in the phone charger and turn off the socket plug, there is no flow of current. And when I turn on the plug, there is a flow of power. Next, for the discussion, electricity can be the source of dangerous electric shocks, burns, or fire starting. So, safety precautions should be observed. A distribution board can also be known as a panel board or a breaker. It is an element of an electricity supply system that will separate an electrical power feed into secondary circuits, whilst providing a protective fuse for each circuit in a regular enclosure. A miniature circuit breaker, or known as MCB, is an automatically operated electrical switch. MCB is intended to prevent damage to an electrical circuit as a result of excess current. They are designed to trip during an overload or short circuit to protect against electrical faults and equipment failure. MCB can manually switch on and off. In short circuit or overload situations, the MCB will automatically trip. This will cause current interruption in the load circuit and rectify the problem. The visual indication of the trip can be seen as the operating knob automatically moves to the off position. The rate of a socket can be tested by socket testers such as multimeter, testband, and load. From the testing, the problem can be detected if a socket blows the fuse or trips the circuit breaker repeatedly. Perhaps it is overloaded or there is a problem with the wiring. Hence, the wiring should not be overloaded with more appliances that it is rated to use. The wiring installation of power circuit can be divided into two types that are ring circuit and radial circuit. A ring circuit provides two independent conductors for line, neutral, and protective earth for each connected socket. If the load is evenly split across two directions, the strength of electric current in each direction is half of the total, which allowing the use of wire with half the current carrying capacity. Ring circuits provide low protection against overcurrent. Also, it is usually supply a large number of sockets and have to be protected with high rated overcurrent circuit breakers that is typically 32 ampere. Other than that, a radial circuit power is transmitted from point to point by a single length of cable linking each point to the next. It starts at the main fuse box and terminates at the last connected device. Intermediate junction boxes may connect individual circuits, individual sockets, or change of several sockets, but there is never a loop wiring structure.
Assalamualaikum warahmatullahi wabarakatuh. My name is Daris Nunazliha binti Zuhrisan and my metric number is CE190061. Okay. In this experimentary, students should be able to draw the house plan and draw the socket outlet point according to the location at home. Also, label all the socket outlet point on the house plan. So, this is, based on the result, this is the house plan. This is the house plan which I drawn with the socket outlet point according to the location in my house. After that, we have to make sure all the socket outlet at home function by testing with socket load, which is charger phone. Connect the charger phone with the mobile phone to test the socket outlet function, which is its function or not. Okay, so I will show the video that I do the experiment of test the socket outlet related to the MCB in my house. This is the distribution board at my house in my living room. Okay, I want to check the socket outlet number 1 and socket outlet number 2. So, based on the MCB, firstly turn off MCB here. This is total 12. So I will turn on the MCB of 12, number 12. And then the rest is will off. And then go to socket outlet number 1. I will turn on the socket outlet number 1. And then the phone is connected. The charging phone is connected with the charge. The phone. It means the socket outlet number 1 is related to the MCB of number 12 here. But, okay, when I turn off the MCB of 12 and the socket outlet is still on, I will turn on, off, and I will turn on. But the phone is not connected with the charge. It means the socket outlet of number 1 is related to the MCB of 12 here. Okay, next I will show for the socket outlet of number 2. This is the socket outlet of number 2 in my living room. Okay, go back to the body distribution board. Okay, I will turn on the MCB of 12 here. The rest all is off. Okay, back to the socket outlet of 2. I will turn on and then go to the phone. See, we can see the phone is charged. Is connected with the charge. It means the socket outlet of number 2 is related to the MCB of the here. When I turn off the MCB of number 12 here, the socket outlet is still on, but the phone is not connected with the charge. It means the socket outlet of number 2 is related to the MCB of the here. After observe the functionality of the socket outlet, and then we have to record the result on this table 4.1. Okay, we can see here this is the MCB. How many MCB there have? I have 12 MCB in my house on the board, and then we have to record the type of MCB, and then we have to know the location of socket outlet, and then we have to record the number of socket outlet related to the MCB. In this experiment, the MCBs function as a protection avoiding overload and short circuit in some of the structures or homes. Lighting for the day, lighting for the night, usually automatic. Socket outlets and kitchen socket outlets are all found in the distribution box. It provided a wealth of information regarding electrical wiring in some homes. We were able to determine the quantity of current consumed as well as the trace on wiring in homes, particularly at the socket outlet. The symbol for drawing the socket outlet and distribution box in a house layout is well known. Okay, so that's it from Micro and me. Thank you.